Chapter 9, this video, we're going over geometric series, this time with the an infinite series. So let's break these down. So geometric, the modality of the actual sequence. So whether it has a common difference or a common ratio, this one has a common ratio. The word series means adding all of these values together. So we're adding every single one of these values. Infinite, these values are going to continue to go on forever and ever and ever. And you'll kind of see why here. So find the infinite sum of the following geometric series. So notice that these numbers start out pretty big, but then start getting smaller and smaller and smaller and smaller. Think about when we were adding, or think about when we were looking at, what are these called? So looking at exponential functions, that as we keep on going forever, we get really, really, really close to zero, but never actually touch it. So we could keep zooming over and over to the very left right there. And these values are going to get so close to zero that it almost looks like they're the exact same line once we taper off to positive infinity. So those values having that little tiny change to an entire series, we're actually adding nearly zero to it. So these end up going to, so adding all of these up together, they end up going to a certain value if you were to add every single one of them up. Because as you keep going on to infinity, you're adding just the tiniest bit. So one millionth of a fraction, even smaller, one zillionth of a fraction, and maybe even values smaller than that. So these values taper off into one specific value. So that's the only time that we could find an infinite sum or an infinite series. So here we have some values that we could make an infinite series, or we could find an infinite series with, but not all of them. So let's see what we have. S sub infinity, so the infinite series, that's why we have infinity instead of n, is equal to a1 over 1 minus r. But we have a restriction. So the restriction is it has to be not equal to, so less than or greater than 1, but also less, or greater than -1, but also less than +1. And obviously our ratio cannot be 0 because we're not gonna not add a bunch of values to it. So the value has to be a fraction. It cannot be -1, 0, or 1. And it has to be within this range in order for us to find an infinite sum. But with that said, we could actually find the infinite sum here. We don't have to do anything crazy. We already know what these values are. A sub 1 is our first term, and r, those are the only two values that we need right now. So a sub 1 and r. So let's find our infinite series. So s sub infinity is equal to a1 is at 162 over 1 minus r. R in this case, let's see, so 54 divided by 162. So 54 divided by 162. Looks like that's 1/3. Let's try 18 divided by 54. Also 1/3. 6 divided by 18, also 1/3. 2 divided by 6, also 1/3. So it looks like our ratio, our common ratio, is 1/3. And from here, let's see what we have. 162 over 1 minus 1/3. It looks like that's going to be 2/3. And keep simplifying. So from here, in order to rationalize this, I want to multiply this by 3. That way those two divide out. But what we do to the bottom, we also have to do to the top. So multiplying those two, it looks like we have 6, 8, So 486, and we're dividing that by 2. And when we divide it by 2, we get 243. And that's it. So we would say that our infinite sum for this geometric series is 243, meaning if we were to add every single one of the values up in this infinite sequence, we would get this right here. And I know it doesn't seem true. We could actually prove it with the following video if we set it up properly. But that's it here. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.